Hello everyone and welcome to my channel. Today we are going to talk about a physics lab about standing waves. How to generate standing waves and how to change the number of antinodes and nodes in this wave by changing the length of the string or the frequency or the tension. So to start with, what is a standing wave? And to know what's standing wave, let's go a little bit back to understand what is a transverse wave. So basically, a transverse wave, it's something like a sine wave that travels in space. Something like when you have a rope in your hand and you start to shake the rope like this, then basically you are creating some vibration in the rope and the rope starts to kind of waving like a sine wave. Or for example, you would say when you threw a piece of stone inside the water and you start to see this kind of wave in the water, and this is kind of a transverse wave that kind of moving along. For our case, we are going to have a vibrator that basically shake a wire, let's say, and this wire is going to create a transverse wave that is moving in this direction. So this is a transverse wave. So a standing wave is two transverse waves. One is moving in one direction and the other one is moving opposite to it in the other direction. Okay? And there's some conditions. First, that they have to have the same speed of movement in the x or in the space itself, and they have to have the same frequency and the same amplitude so that we can create a standing wave. So basically, this wave should be going in the opposite direction. So basically, it's as if we have another wave like this. So the combination of these two waves, it's acting as if it's a standing wave. A wave that has different nodes, 0 parts. I know it's not like this. I will draw it in a better way. But basically some 0 points, we call it nodes. These ones, a node. And this big amplitude, we call it antinodes. So points of constructive interference or interaction, and these nodes is basically destructive interactions and they kind of destroy one another. So this would be a standing wave. So let's draw it in a better way. So all these nodes are on the same line and they have the same amplitude. Sorry, it doesn't look like exactly as a standing wave, but I think you understand how you got the idea itself. So here, the number of antinodes, it represents the mode of operation. Okay? So how to do this in real life or in our example, what we are going to do is that we are going to get a string and we will attach the string here for a vibrator, some device that's basically vibrating, and create a transverse wave. And basically, to have a wave with the same amplitude, speed, and everything, we have to have a fixed point here. So we fix after some length. So this is a wire or a string, it has certain length. And after a certain length, we are going to fix this point. So what happens here, when the string starts to build the wave, it's going to hit this fixed point and it's going to reflect back again the waves inside. Okay? However, let's see, for example, how we can have it like this. This is a sine wave or transverse wave that's moving in the wire, but basically it hit the fixed point before the node. Okay? So at this point, I'm not going to create a standing wave because if this one reflected, it's going to be what? It's going to be something like this. You know? something like this. So it's not going to create a standing wave. Only when the generated or the vibrated wave is basically reflecting at the fixed point exactly here, let's say at the minimum of the sine wave, at this point the reflected one is going to be like this. And here we have a standing wave. The lambda of a standing wave, lambda is basically the duration or like the length of one cycle of the wave. Okay, so usually we call this one as a one cycle, lambda. Okay, for any sine wave, if we have this wave, for example, this is a one cycle, and this one cycle has a lambda. Lambda is in terms of dimension or centimeters or meters. This cycle happens during a time period of t, and basic t is equal to 1 over f, which is how many cycles per second. Okay? So, the most fundamental standing wave is going to be a wave like this. Only has one antinode and two nodes. Okay? And this standing wave is going to have a lambda of 2L. L is basically the length of the string. And here we have a resonance. If we have two antinodes, that means we are in the second mode. So basically this is going to be something like this. So this is two antinodes and three nodes, and this, in this case, lambda is going to 2L over N. N is basically the number of antinodes, and it also represents the mode of the frequency or the resonance frequency. So if N is equal to 1, that means the fundamental frequency. If it's equal to 2, that means we have a second harmonic. 3 means three harmonics, and 3 means we have 3 antinodes, something like this. Okay? I hope you got the gist of it. We have 3, 1, 2, 3, and so on. You can increase it as much as you can. So the wave here travel with a certain speed, and speed has a unit of meter per second. And this speed is equal to lambda, the wavelength, multiplied by the frequency, how many cycles per second. Okay? And also this is equal to, for the string case, it's equal to the square root of tension over mu. And mu is the linear mass density of the string itself, which means that mu is equal to the mass of the string over the length of the string itself. From this function, we can see that lambda is equal to 1 over f, the frequency multiplied square root of tension over mu, which means that the wavelength increases if I increase the tension, and also the wavelength increases if we decreased the frequency. So this is a way that we could change the lambda of the wavelength, and basically we create different modes. So I hope you got the gist of the standing waves, how to change or to increase the antinodes. Increasing the antinodes, basically that means lambda is equal to 2L over N. So if I need N to increase, that means basically I need lambda to decrease. And to make lambda decrease, we basically either to decrease the tension on the string or to increase the frequency that we vibrate the string with. And the tension here is basically at a normal stage. We take this string and we tighten it and we kind of pull it from the fixed point. And in our case, we are going to have a pulley. And this string is going to go around it. And this is going to be the second fixed point of the string. And this string is going to have some weight, some mass that we could change. And basically, the mass determines the tension, because the tension is equal to mass multiplied by g, the gravitational force or the gravitational acceleration, which is g itself is equal to 9.8. By changing the tension on the string or the supplied frequency, we can play with the wavelength value and create more antinodes or less antinodes. So in our case, just to show you the setup, we are going to have this side, we're going to have the vibrator that vibrate and create some signal with a specific frequency. And the other side, we are going to have it around the pulley. Okay, and basically we have some tension or this weight. So by doing this, we can start to create some vibration, and we start to have some of the antinodes, something like this, this is basically has how much N? What do you think? It has 4 antinodes. So the lambda is equal to 2L. Let's say the length is 1 meter. It has 2 multiplied by L, which is 1 meter, over N, which is 4. So this is going to be 0.5 meter, and this is the wavelength. And basically, we can determine the other stuff. For example, I hope you got it. So let's go for the lab and do it.